Today we were looking at what happens when we change scales in scale drawings. So we're going to, given a scale, I can create another scale drawing that shows the same thing at a different scale, and I can use scale drawings to find actual areas. So we were looking at a map of the neighborhood of Philadelphia, and there's a park in this triangle-shaped piece of land, and it gives us that the actual base of the triangle is 120 meters and its actual height is 90 meters. What's the area of the plot of land? But before we found the area, we had to make scale drawings. And so some of you had a scale of 1 centimeter to 5 meters. Some of you had a scale of 1 centimeter to 50 meters, 1 centimeter to 20 meters, 1 centimeter to 10 meters, 1 centimeter to 30 meters, and I think we even had a 1 centimeter to 15 meters. And we made some drawing. The first drawing we're going to look at is we're going to do the 1 centimeter to 5 meters. And so my park, the base of the triangle is 120 meters long. So to go from centimeters to meters, we multiply by 5. So we're going to divide 120 by 5. And we're going to get 24 centimeters. And then our height, 1 centimeter to 5 meters. Height was 90 meters, so 90 divided by 5 is 18 centimeters. So assuming that this grid paper is centimeters, and there is our park that is using the scale of 1 centimeter to 5 meters. If we do the 1 centimeter to 10 meters, now to get from centimeters to meters, I'm multiplying by 10. So I need to do 120 divided by 10 is 12, and 90 divided by 10 is 9. And I'm going to draw that inside. So this is 9, this is 18. And we looked and we saw, wow, this scale to this scale, I'm multiplying the meters by 10. But the scale factor from drawing 1 to drawing 2 is 1/2. 18 times what equals 9? 9/18 is 1/2. So I doubled the number in the scale, and it made the drawing half as big. Well, I wonder what would happen if we used the 1 centimeter to 50 meters. Now we're multiplying centimeters by 50 to get our meters. So when I know the meters, to go backwards, I need to divide by 50. And so if you do 90 divided by 50, you get 1.8 centimeters. And 120 divided by 50 is 2.4 centimeters. So my base is 2.4 centimeters. My height is 1.8 centimeters. And to go from this first scale to the second scale, we're multiplying the number of meters in the scale by 10. If we look at the scale factor from the first drawing to my third drawing, 18 times what equals 1.8? if you do 1.8 divided by 18, you get 0.1, which is 1/10. And remember, numbers like 10 and 1/10 are called reciprocals. So it seems like whatever we multiply the number in the drawing by, in the scale by, we multiply the drawing by the reciprocal. And so here's my works. I know they're turned sideways. I can't get them to turn the other way. But to go from 15 to 30, we're multiplying by 2. And if you look at the side lengths of the second drawing, they are half the side lengths of that first drawing. To go from 20 to 50, we multiply by 2.5, or 5 halves. If I look at the side lengths, 4.5 times what equals 1.8. 1.8 divided by 4.5, well, that's the same as 18 divided by 45, which is 2/5. So the scale factor from the drawing with the 20 meters to the drawing with the 50 meters is 2/5. And 5 halves and 2/5 are reciprocals. Then we were to find the area of the original park and then the area of each of our scale drawings to see how they compare. So remember, our actual park had a base of 120 and a height of 90. So multiply those together and divide by 2. We end up with an area of 5,400 meters squared. So I'm going to go through and find the area of each of these triangles that we drew. Our large one has an area of 216 square centimeters. This one has an area of 54 square centimeters. This one has an area of 24 square centimeters. Our 1 to 20 triangle has an area of 13.5 square centimeters. The 1 centimeter to 30 meters has an area of 6 square centimeters. And the tiny one over here has an area of 2 1600ths square centimeters. So when we compare these to the original, if I take my original and divide it by 216 for this first one, we end up with 25. And thinking back to area factor, remember the area factor is equal to the scale factor squared. If I look at the numbers in my scale and I square each of them, for this one I end up with 1 square centimeter to 25 square meters. And there's my 25. And so knowing that can help me find my other areas. Because if I thought about 1 centimeter to 10 meters, that would be 1 square centimeter to 100 square meters. My original area is 5,400 square meters. I'm multiplying the centimeters by 100, my square centimeters by 100 to get my square meters. So going backwards, if I divide by 100, 5,400 is equal to 54 square centimeters, which is what we got in the first place. Thinking about 1 centimeter to 15 meters, squaring that, 1 square centimeter to 225 square meters. We knew the original area was 5,400 square meters. To go from square centimeters to square meters, we're multiplying by 225. Going backwards, I can divide by 225. Why does this matter? Well, if all we had was the drawing and the scale, and I didn't know the original measurements, I could find the original area using the scale by squaring the scale. I know this area of this drawing is 6 square centimeters. To go from the scale to what I have, I'm multiplying by 6. So if I multiply 900 by 6, I end up with 5,400 square meters, which is what we had originally found our area to be in the real life park. So just like area factor is equal to the scale factor squared, when we talk about scale, if you square the scale, it will give you the scale for the area.